And welcome, everybody. I'm glad you're joining us this evening. We have our first meeting of the Puget Lobe chapter of the Ice Age Floods Institute starting tonight. We have a lot of giants lined up, starting with Dr. Karl Lillquist this evening, who's going to speak to us about something that I am very interested in hearing about, Foster Creek and Foster Coulee. And I know many of you share that interest. Coming up next, we have Jeff Tepper, and he's going to be talking about the initiation of the Cascades about a month from now, actually, on the 10th of November. And then coming up in January, we have some other speakers coming up that are going to be very interesting. So some giants coming up this week or this fall and winter in this lineup we have here. Well, Dr. Lillquist has been interested in the Ice Age floods and the topography around the Waterville Plateau and the Scablands for a very long time. He grew up in the Scablands, basically. He has taught at Central Washington University for a very long time, been involved in a lot of research projects, and has taken many students out into the field. We're very fortunate that Dr. Lillquist is willing to speak with us tonight by Zoom. And well, welcome, Karl. We're very glad that you're here.
Great, great. Thanks, Dale. Um, it's a pleasure to do this, and I retired a year ago, and I've been staying active leading field trips, but I really haven't given any presentations. So I hope there's not too much rust on my speaking. And like I was telling Dale before we started, somehow I lucked out during COVID and was able to avoid much of the Zoom kind of stuff. So if I hit a rough spot or two, Dale's going to coach me through it. And so here we go. As an introduction, and don't walk away and go, oh my God, there's all kinds of text. There's just a couple text heavy slides, and the rest of this will be pretty light. But let me give you a little intro. There were mainly geologists, maybe some geographers as well, that early on saw that Foster Coulee and the Foster Creek valleys had some unique characteristics. And these included being close to the Grand Coulee and Moses Coulee. East Foster Creek was oriented differently than other drainages in the area. This was an area that was once covered by a large glacier, and now a lot of it is mantled by sediment. So it's got some characteristics that kind of hopefully get you thinking a little bit. So the questions that I want to explore with you tonight, and you're going to see that I don't have all the answers, will include these. So did glaciers and huge floods shape Foster Coulee and the Foster Creek valleys? And if so, when? How are Foster Coulee and the Foster Creek valleys related to Grand Coulee and Moses Coulee? Those are two coulees that you've heard of, I'll bet. What was the relationship of Foster Coulee and the Foster Creek valleys to Pleistocene lakes? I'll define Pleistocene here in a bit. And then right at the end, I'd like to kind of try to bring you to present day. Most of tonight's talk is on, really, you could think of it as late Pleistocene, or what you might more commonly call ice ages. But right at the end, I want to try to bring you up to present and show you some work that a couple of my graduate students have done, and just give you just a tidbit of that. So Dale walked you through a little bit of my background. I wanted to say a couple other things. I grew up on the Columbia Plain, and much of my growing up, I spent, I think, what was it? 12 of my first 18 years were in Coulee City. and the other 6 years were up in Oroville, up the Okanagan Valley. And especially Coulee City is pretty near Foster Creek drainage, and I worked on a wheat farm just south of the Foster Creek drainage. During my 29 years at Central Washington University, I spent a lot of time really kind of dabbling and then at times getting into it more deeply, looking at various aspects of the Foster Creek drainage. I had, like I mentioned a bit ago, I had 2 graduate students that did really good work on this drainage. I had a couple undergraduate students as well who did undergraduate research projects. And third, I had classes out here almost every year and sometimes twice a year, including a field school one year. So this was a great place to bring students to. Many of Central Washington University's students come from Western Washington, and this was like the moon to them. When you look at a landscape like you can see here in this photograph, this is a very different place. So with that intro, let me now kind of introduce you to where we're at. And I'm going to start with the Columbia Plain. Some of you might call this the Columbia Plateau. Some might call it the Columbia Basin. And for you Puget Sound folks, you're over here. And Dale, can you see me circling that or not? Okay.
Yes,
So,
yes.
okay. So you're there. We're over. What we're talking about is here in kind of the northern part of the Columbia Plain. A good chunk of that Columbia Plain is known as the channeled scablands. That's a term I'll bet you folks have seen and heard, and that's classic Ice Age flood landscape. If we go to the northern part of the Columbia Plain, the Waterville Plateau sits kind of surrounded by, it sits on the northwest part of the Columbia Plain, and it's bounded by the Columbia River that I'm tracing here, and bounded on the east side by the upper and lower Grand Coulee, and then on the south by the Quincy Basin. And finally, if we go to the northern part of the Waterville Plateau, I've highlighted the 3 branches of Foster Creek. East Foster Creek stretches out almost to Banks Lake, and it's the really enigmatic one of those drainages, and I'll take you to that in a bit. And then the middle fork of Foster Creek and the west fork of Foster Creek here. And you can see the Columbia River to the north and Bridgeport to the kind of northwest. Okay, so that's the layout. Here's some observations. And first off, this is a place of semi-arid climate at present. It's dry, and when you see it in the dry season, it looks dry. It's shrub steppe covered, and the only wet places are really in some of the valley floors. But we're getting near the margin of east side forest, and so on some of the north facing slopes, you'll see ponderosa pine and even Douglas fir. But precipitation here is 10 to maybe 12 inches a year. So it's dry. And compare that to, if I remember right, with Seattle, 39 to 40 inches a year, something like that. I've put a very, very bare bones, and actually my symbology is not great, but you see a stratigraphic section, a bare bones stratigraphic section on the left side of the screen. And I use a term, I use three terms that you may not be familiar with. There's Cretaceous granitics, Cretaceous granitics and metamorphics that underlie this area, and they outcrop in a few places. These are real ballpark, and Jeff Tepper can definitely refine this. These are 90 to 100 million year old granitics and metamorphics. And so this is Mesozoic stuff. And then there's tertiary basalt. These are the Columbia River basalts that we'll generalize and say these are about 17 to 14 million years old. And then they're overlain by glacial outwash and till, glacial lake sediments, and loess, so wind-blown material. All of that was deposited in the Quaternary, and we'll generalize and say roughly in the last 2.6 million years, somewhere in there. Okay, so these are, this is kind of what we're dealing with today, and our focus is going to be on these lake sediments and a little bit on the outwash till, but you'll see in some photos the basalt outcropping. Okay, so that's the setting we're dealing with. And now if we look at a LiDAR image, we can see that landscape a little differently than you did on the earlier Google Earth image. And I've highlighted here a part of East Foster Creek called Foster Coulee. That's the upper part of that drainage. And I'll take you back there in a little bit. So you get a sense of this, and you know, there's the plateau is quite planar. The Waterville Plateau is quite planar, as you might expect, but it's cut by drainages in places. We're seeing the headwaters of Moses Coulee over here where I'm running my pointer. And we're seeing Horse Lake Coulee here above Banks Lake on the right. So there's some local relief, but it is a higher plateau. Okay, so if I go back here, I've used this term coulee, and I wanted to make sure that we're all on the same page. So I raised the question, what is a coulee? And if you go to the Encyclopedia of Geomorphology, geomorphology is the study of landforms. It's been defined as a dry valley, canyon, gulch, or wash. So let's think dry valley for the moment. And many of these formed in late glacial times when there was a lot of meltwater coming from glaciers via proglacial lakes. And a proglacial lake is just sitting out in front of a glacier. These coulees are often steep-walled and flat-floored, flat being relative here. And this is a classic shot in the background. This is Lower Moses Coulee, and it's awesome. It's an awesome example of a coulee. There's those steep walls, and the floor here has got a little bit of relief, but not a lot to it. So I think flat-floored works here as well. Okay, so think about now, what are some famous Scablands coulees? I've already mentioned a couple of them. The Upper Grand Coulee, my northernmost arrow, the Lower Grand Coulee, Moses Coulee, and then what are those two down below? What are those two to the south? One of those is Potholes Coulee in the Quincy Basin. That's the northernmost. And then Frenchman Coulee, the further south, is another. And we could go on. There are other coulees around, but these to me are kind of the most famous in Washington. Here is Foster Coulee. And I'm laughing because this isn't quite what you see with Moses Coulee. It's a little bit more subtle. We're looking upstream, we're looking east, and but this is a coulee. It's been called a coulee nonetheless, and so we'll go with it. So this is Foster Coulee. The entire drainage is not all this way. So if we turn around now, we head downstream into what are more just called valleys. Here is East Foster Creek Valley, and this is kind of midway down in the lush spring. This is May of a couple years ago, and things are green and lush, and you get just a great view here. But notice how the landscape, you're not seeing much basalt outcropping in the foreground. You see kind of a muted or a blanketed look, and that is the sediment that I talked about earlier. Said there's a mantle of sediment, and boy, that shows up down in these drainages. Here's the West Fork of Foster Creek, and kind of an older photo, and a little bit darker, maybe not as lush looking, a lot of sagebrush. And this too looks a little more muted down low, although you can see some basalt outcropping up here up above. And then this is Middle Foster Creek, and it's kind of hard here to see where the drainage itself is, but it's winding up something like this. And this is in November of the year, so things look quite different. But again, a pretty muted, blanketed looking landscape. And in this setting here, in each of these settings, it's kind of different types of sediments that blanket this. In this case, there's a lot of sand in this environment. Okay, so I'm going to move my microphone just a bit so I can watch the time. Okay, so now I got to look here. There we go. Okay, so the other thing I mentioned early on is that these Foster Creek drainages are adjacent to Moses Coulee here to the south, Upper Grand Coulee to the east, and then the Columbia River Valley around there on the margins. Okay, and this area was absolutely shaped by the Okanagan lobe of the Cordilleran ice sheet. Where you are in the Puget Sound area, you were, unless you're south of Olympia, you are out of the direct effects of the Puget lobe, which was also part of the Cordilleran ice sheet. Where I'm talking about tonight, it was covered by the Cordilleran ice sheet. And the important thing to keep in mind with glaciers and glacial work is that glaciers often erase. So when one of the dilemmas here is, were there multiple glaciations? And a problem, if the earlier glaciation isn't more extensive, it may be obscured, it may be erased by a later glaciation. And so that's something that we battle in looking at glaciated landscapes. So where my star is here in the center of the image, center of the map, that was under the Okanagan lobe. I thought I'd throw in a photo to show you some of the, or a map and a small photo showing you that J. Harlan Bretz, who is our guide and our kind of key scientist, key geologist in figuring out the Missoula flood story, Bretz mapped this as well and mapped the Okanagan Lobe here in this kind of light blue color. And again, I've put a star where generally, very generally, where we are talking about tonight. Okay, so that's the layout. That's the intro. So now, taking the work of Bretz and many others, at least one before him and a number of other researchers after him, let's think about the origins of this landscape over time. So these are interpretations, and most of them are not mine. And so I will try to point out who the researchers were that did this. And we'll start off, we're looking kind of, we're in central East Foster Creek. We're looking upstream again, kind of near that neat green May picture a few images back. And here we go. So an early researcher in the general area, Richard Foster Flint, was looking more at glaciation in the area, but it's hard to separate glacial and ice age flood activities in this area. Those two interfinger, and you'll see that as I roll along here. Flint had this map in his 1935 paper, and he shows Foster Creek and Horse Lake Coulee in this area where I have pointed with a red arrow. And he shows actually the three branches of Foster Creek. And he called this upper part of Foster Creek that I'm circling now Foster Coulee, and he said that Coulee cutting dates back to an earlier ice occupancy. So right off, we look at this issue of, were there multiple glaciations here? He didn't offer any evidence for that early ice occupancy that I recall seeing in that paper, but he attributed it to an earlier glaciation. And so with this, what we're talking about now is Pleistocene glaciation and of the Okanagan Lobe, but think in terms of early. He's trying to get us to think about earlier than latest Pleistocene. Then along come Bruce Bjornstad and Gene Keever. Keever was a faculty member at Eastern Washington University for a long time, and Bruce Bjornstad was one of his students. Bruce has since written two really wonderful guidebooks on ice age and glacial stuff in Central Washington. If you don't have them in your library, think about getting them. They're wonderful sources. They argued that East Foster Creek and Foster Coulee was a early pathway for just normal stream flow. And so I'm showing that with the yellow arrow. And notice that I've put an X across Banks Lake. Banks Lake it lies in the upper Grand Coulee. And so what I'm trying to pass on to you is there was no Grand Coulee at the time they show, at the time this creek did what they're showing, right? it doesn't work to essentially to have a stream cross a coulee. It's impossible. So the coulee was not here, and they've got the headwaters of Foster Creek extending clear up on the uplands to the east of what is now the Upper Grand Coulee. Some people might call this the Heartline Hill. This is uh, east of the Upper Grand Coulee and north of Heartline and Coulee City. So they're showing stream flow down to the west, and I've put the elevations of that area as well. So you can see that when you go from the edge of the Upper Grand Coulee at 2,100 feet, and when you drop down to Bridgeport, it's 800 feet elevation. So it makes sense. The water is flowing from essentially east to west. And I say that I make that very basic point, but the story is going to change later. So just keep that in mind. Okay. So that's Bjornstad and Kiever. They're showing a more extensive East Foster Creek. And the other thing I'll raise here is we don't know what was going on in the West and Middle Forks, and did they even exist pre-glaciation? And I'll come back to that point in a bit. And then Richard Waite, a USGS researcher who has looked at Central Washington and Eastern Washington ties to the Okanagan Lobe and Missoula floods for years. I think his PhD dissertation was up in the Met Howe looking at the Okanagan Lobe. But he's looked at this area for a long time. He would argue that he doesn't show that stream crossing what is now Grand Coulee, but he would argue that, or he would agree with Bjornstad and Kiever that, yeah, there's flow down to the west. And he shows it, and this is a figure from one of his papers. He shows a creek, what he calls Coulee Creek, that occupied a very shallow valley that later became the Upper Grand Coulee. And with this, it would make sense to me, he didn't draw it on here, but it would make sense to me if he would have shown a drainage coming, going from west to east as well. If you follow me there, flowing down into Coulee Creek. Okay, so now if we move more into the late Pleistocene, so now think 18 what I think a good date would be 20 to 18,000 years ago. And now have an Okanagan Lobe expand to the south. And so I've drawn this line showing that would be the southern limit of the lobe at this time, and have it block the Columbia River Valley. And when that happens, that impounds water behind it. So you've got an ice dam, and it creates Glacial Lake Columbia. At that time, there's no Upper Grand Coulee still, at least not eroded to the northern part of this. And so the floodwaters go across the high area and into the east end of Foster Creek. And so the argument here is this is how you make essentially Foster Coulee. So floodwaters diverted by an ice dam. And actually, let me back up. So a Columbia River plus floodwater creating glacial Lake Columbia. That water has to go somewhere as it rises. It flows across the landscape and into the Foster Creek drainage and then down into the Columbia below, and then it continues south. Here's Foster Coulee from another view. And so now visualize that Columbia River and Missoula, early Missoula floods going through this drainage. And this drainage in places approaches, oh, it's 2/3 or so of a mile wide and maybe a couple of 100 feet deep. Let me check my notes here real quick. If I wrote that down. I did not, but at ballpark, less than a mile wide and 100 to 200 feet deep. And so this would be an early floodway for these Missoula floods and for the just normal flow of the Columbia. There's a problem with that I still struggle with, and that is, okay, if that's the case, where are the giant flood bars? Usually you'll see flood bars in these drainages, and they're more rare. The more rare features that we also don't see here are the giant current ripples as well, like are so prominent at West Bar, for example. But I'm not as bothered by that, but I can't see when I look at topographic maps, aerial photographs, and LiDAR, I can't readily pick out giant flood bars. But it is an overfit valley. That is, the valley is way, way bigger than the present day stream. And I'm showing you here East Foster Creek that you can literally step across at in the summer, and you're in a valley here. We're a little bit downstream of that last view. So here I measured it today. This is 1/3 of a mile wide for the floor. So this is, to me, is good evidence of past bigger flows, maybe flood flows. But like I pointed out back here, the giant flood bar part is a little bit problematic. And I'm not, all I'm saying is I don't see the evidence. What's been put forward here makes sense, but I don't see clear-cut depositional evidence. Okay, so, but boy, what we do see with this are scablands. And so you're looking down on a scabland setting here. All these dark features are lakes and ponds, but more accurately, they're ponds. And the dark surface underneath, where I'm kind of working my arrow around on right now, is basalt, and it's scoured basalt. If we were to get out on that surface, I would bet you folks we couldn't put a shovel in more than a couple inches. This has been scoured by flooding, and it is really classic scabland terrain. The other oddity here, beside the lack of flood bars, is that the coulee essentially ends, or at least the naming of the coulee ends at about what's called Leahy or Leahy Junction. This is right here. And this is on Highway 17. And below that is where the character of that valley changes to where I showed you the more mantled area. So you've kind of seen this in several forms of media now. If I bounce back, you're seeing this on Google Earth. Here's a classic topographic map view, and then you've seen LiDAR imagery for this area. So the question here is, why does the Coulee and the Scabland end near Leahy Junction when that water continued to flow? It makes sense. It flowed west and down to the Columbia. So I've mentioned Glacial Lake Columbia, and this has a ballpark date of about 16,000 years before present. And I show how I came up with those numbers with what I've got written down below. But Glacial Lake Columbia, I've got it arrowed to with a red arrow. And so that would have been the source of these waters. And now if we put the Okanagan Lobe in a different position, this would be just the geometry of that lobe is different, and we block the Columbia River Valley down near Brewster instead of closer to Grand Coulee. We get a lengthier Glacial Lake Columbia that had the potential to backwater up Foster Creek, especially, and we're going to focus on East Foster Creek. Because again, I'm showing here a dash lines for West and Middle Foster Creek. I'm not convinced these are even in place yet. They may be, but
Hello.
yeah, hello. So with this, we've got water moving upstream now. Okay, so with that, where does that water go when it goes upstream? There's two options, and Richard Waite has been an advocate that this is one way that you can put water into Moses Coulee. This is one way to create Moses Coulee. So if you've got water backed up into the East Foster drainage, and then it goes over a threshold here if it gets high enough, and it sends water into this area and helps erode Moses Coulee. So that's one possibility. And actually, I got ahead of myself. That would be this option. So one of the things to think about with this that has been argued about for years is, how do you create a Moses Coulee when there's no direct paths of flow to it, and at least no obvious direct paths of flow to it? This is one way to do that. The other thing, now if I back up, the other thing that could have happened is this water could have just been pushed up the Foster Creek drainage into Coulee Creek, and then followed that Coulee Creek southward. Okay, it's complicated. Lots of options to think about here. So this is Richard Waite thinking on that. And so now have that Okanagan Lobe advance south. And this is where we get a little bit more concrete dates involved. By about 15,400 years ago, the Okanagan Lobe was at its maximum position at what we call the Withrow Moraine. That's what's here, this white line here on the south. That ice at the Withrow Moraine was probably about 700 feet thick or more. On the north end of the plateau at the glacial maximum, the ice was thought to be closer to 1,600 feet thick. So you start thinking about this, 1600 would be what, a third of a mile or thereabouts. This is thick ice. What was the Foster Creek drainage? What was happening in that at this time under full glacial? It was likely it was buried in ice, but this might have been, as the ice passed through, it might have been what eroded, especially West Foster Creek and parts of Middle Foster Creek. In other words, they're more aligned with the direction of ice flow. And let me pause for a second. Dale, you want to remind me how I turn on my little drawing thing?
There should be a tool on the bottom, an annotation tool. Do you see
Yeah,
that in your toolbar?
I'm yeah, whoop, whoop, whoop. I'm not seeing that toolbar on this screen. Hold on. Is it uh yeah, it's not there.
If
Whoop,
not, do you see a little green pen on the left side of your screen?
I don't. Yes, I do. There we go. Okay. So if I draw, whoop, hang in there, you guys. So with that, can I, yeah, that's right. I'll use my pointer. So the, when this ice moved down from the north and moved onto the Waterville Plateau, it radiated out. So it flows. If you just follow my pointer here, it flowed like this. And I'm just going to work around here like that. And you can see that if you pull up Google Earth later and you look, you can see the lines that really, the flutes and the uh, valleys that really follow that pattern. So it's conceivable that those two drainages, east, or excuse me, west and middle, have owe at least some of their origins to this advancing ice. But the East Fork, you look at that drainage is running counter to the direction of ice flow. I don't know that ice had played a big role in shaping it other than depositing sediment in the valley. Okay, so um, Joel Gombiner and Jerome Lessman just published a paper in the last year, and it was based partly on Joel's PhD dissertation that was looking at the origin of Moses Coulee. And they argued that Tunnel Valley floods from the Okanagan Lobe reached Moses Coulee, and they would have had to have passed over and through part of the Foster Creek drainage. So here's just in a nutshell, what we're talking about is tunnel valleys are valleys that form beneath ice sheets from pressurized water. And they argued that there was a lot of water under this relatively warm based glacier, and they presented evidence for that. And that water was the key source to get into Moses Coulee. And they make a good argument because the radial flow of these drainages, you can kind of see them radiating. There's a good part of those that head right toward Moses Coulee. So again, East Foster Creek and possibly West and Middle were feeling some of that Tunnel Valley flow. Okay, so now in the latest Pleistocene, that Okanagan Lobe started to retreat, and by the time it got back to nearing Bridgeport, it, uh, I would argue it was impounding a lake, and that lake was named by Larry Hansen as Glacial Lake Foster. And it was what you might think of as a river lake, and that is water it's impounding water, but the water, especially in the East Fork, was slowly moving to the east and spilling into what was now an eroded Upper Grand Coulee. And that Upper Grand Coulee likely formed and finally opened up into the Columbia River Valley by 17 to 15,000 years ago. Okay, so if we back up just for a second and we go here, we had a glacier that was at its maximum extent at about 15,000, according to these dates. And that, that glacier left evidence in the Upper Grand Coulee. So we could refine this a little better and say, hey, it's closer to, it was before 15.4 thousand years ago that this coulee was open to flow. That makes things interesting here, and I'll show you this in just a second. So what's the evidence now in Foster Creek, in the Foster Creek Valley, for this glaciation where the glacier has passed over on the advance and has now retreated back? Well, there's glacial outwash that shows up in road cuts. That's what this gray stuff is. And sitting over the top of it are glacial lake sediments. And they are sitting in a basalt walled valley. So the basalt isn't stratigraphically above, but it's in the valley wall, if that makes sense. So we've got outwash deposited by meltwater, and then we've got that water, that meltwater, leaving fine textured sediments that sit on top. So in that valley, there are landforms that tell us that this was covered by glacial ice. And there is a classic near Leahy Junction. Here is a classic esker. This is an old stream channel beneath the ice that was filled with sediment. And there's another one down here that's not so classic. These are called eskers, and they tell us that that Foster Coulee was in place before the last glaciation. Here's a close-up of glacial lake sediments. An early researcher, I.C. Russell, an early geologist, talks about here the fine white silt and clay in these sediments. And he was the first that I know of that attributed these to a lake. So you can see the bedding here in those glacial lake sediments lying again on top of glacial outwash. Okay, so what's the other evidence that we see here for a glacial lake? Well, I'm arrowing here to a terrace in Glacial Lake Foster, and this is not at the highest shoreline, but it's kind of midway down, I think. And how do you get terraces? Essentially, if the basin gets filled up with sediment, so think of this basin as being filled with sediment this deep, stretching across this area. And then when there is outflow, when that lake drains or when lake levels drop, a lot of that sediment is eroded and transported downstream, and it leaves these terraces along the sides of the basin. This looks like a terrace, right? You can see that flat top, but it's actually a delta. And these are even neater in that these form at stream mouths, and they take on an inverted V shape when you look at them from above. So there's a stream mouth here. I think it's over here on the right. And this is what's left of a big delta. check this out. Now I'll show you it on a LiDAR image. Here's the delta. It's, this would be probably a quarter of a mile across anyway. And this formed at the mouth of a stream that came right out like that. And this formed at the high shoreline, at the high lake level, at about 2,100 feet. In that same area, I can identify at least two other deltas. They don't look quite as clear cut, but they are fabulous as well. There's one right here along the highway that is just chock full of gravel and sand. And so it's been a long time Washington DOT quarry site. And there's another one down here in the lower left that is also a well-developed feature. So there's deltas, and these can help you pin down how high the lake reached. They should form at close to the high lake level, just like terraces should as well. So how deep was this lake? And I've surveyed up to 2150 feet. There's a delta right up here on the north end. And right down in the bottom there at 1730 feet, there's lake sediments. So if I did my subtraction here correctly, the lake here in the chalk hills was 420 feet deep. That's impressive. And it left a lot of lake sediment here as well. And I'll show you a bit more of that here in a little bit. In those, if we get in close to the chalk hills, this is one hill, and you can see bedding in this, these horizontal beds. And if you really start to clean that off nicely, you can see kind of light layers, dark layers, light layers, dark layers, that if you put those together, each one of those is called a varve, and the varves represent 1 year. So the dark sediment, if I remember right, is deposited in the winter, the light in the summer. And so these can give you a sense of how long the lake was here. And this is some of the work I need to do now in the future, is essentially go out and set up a ladder, because we're taught in these hills, you can see these are pretty steep and tall, and I need to carefully scrape, come down these faces and count varves to try to figure out how long the this lake was here. And this will give me a start anyway. I can't get to the bottom of this, but I can at least, did this lake sit here for 200 years, 400 years? What? That's a question that's not answered at the present. So how old is the lake? So a minute ago, I was trying to get you to think about how many years did the lake occupy this basin? Well, now, when was the lake here? And I've got an optically stimulated luminescence date on the delta up to the north of the chalk hills. And this says about, and there's a lot of wiggle room in these dates, like about 1,000 years. So I'm giving you a very approximate date of just under 16,000 years. If you've been tracking on this, you know that doesn't follow real well the date on the end moraine, the Withrow moraine. That this is older than that, and it should be younger than that. But keep in mind, it's different dating methods. This is OSL. It was, I think, chlorine 36 used on the moraine. So we're in the ballpark, but we're not as precise as we might see with radiocarbon dating. Okay, so hang in there with that little discrepancy. We're in the ballpark. And if you step back out here's other dates that I've collected on lake sediments in the basin. And I think one neat thing with these is these are all within about 1,000 years, which is the kind of the standard error in this OSL dating. They're ballpark. It's late Pleistocene, and so the white dates are pretty good. I thought I'd be honest with you guys and show you where it's not so good. The yellow are places where I've dated. You can see I spent a lot of money over here on the right trying to get a date out of that big DOT gravel pit, and I wasted a lot of money there. I can't get that to work. Oddball numbers. But and the same to the west. I got two kind of oddballs there, but the rest of those other five group pretty well in my view. So let's call it 15,500 or something like that for ballpark for average on all those. Okay, so now I'm looking at time here. I'll see if I can wrap this up. So Glacial Lake Foster, earlier I'd said that the water has at several times flowed from west to east, and evidence for that is sitting in a excavated upper Grand Coulee where there's a big delta, and that delta formed right below East Foster Coulee. So sediment was transported from west to east and deposited in a Grand Coulee when Glacial Lake Foster was at that high level, that 2,100 feet or above. That's pretty wild. You've got a drainage that has flowed from east to west, and we've got evidence west to east. And this must have been glacial meltwater coming here for this to form. And here's a view if you've been up on Steamboat Rock or if you've been in the upper Grand Coulee. Here's a view of the delta. It may kind of not be real impressive to you, but right above that is the eastern mouth of Foster Coulee. And then the Cascades in the background. Okay, so finally here in this lake story, as the glacier retreated, it may have allowed some floodwaters to come down because there were some smaller late floods and also Columbia River water just coming down, and it backed up some in this lower part of Foster Creek drainage. And it left some huge terraces. And these are different from the fine lake sediment terraces that I mentioned up above. These seem to be cored with sand and gravel. So let me show you. I'll give you two views here. This is looking downstream, and I'm highlighting here 4 terraces. 1, 2, 3, 4. And I know on the side of the valley there's sand and gravel. And if I turn the view around and look up valley, here's that sand and gravel would be over here, and there's that terrace sequence. So a real enigma here is, why do you go from these fine textured lake sediments just several miles upstream to now down here a sand and gravel dominated system? And it makes sense that you've got to have some flood flow back up into this drainage and creating this kind of clean sand and gravel. At least that's what Larry Hansen has argued. Okay. The terraces each may represent a level of the lake as the lake receded, as the lake dropped here. So sediment flushed up in here and then holding the lake, and then essentially that lake drops, erodes into that sediment, and creates a new level. Okay, I'm going to skip this, just looking at time, and if questions come up, I can come back to that. Let me take you now quickly through the post-glacial period. So the lake's gone, the glaciers are long gone, and so we're left with what has been termed badland topography out in the chalk hills. And you've seen a couple of these shots already. But think of these as remnants of the once more continuous fill of those fine textured lake sediments. And again, we're probably 5 miles upstream of those sand and gravel terraces. That badland topography was once farmed, and that just blows me away. Or the areas around the hills were farmed, and that's what's shown here in this light color. And I wrote here dryland wheat, but that same stuff over here was all dryland wheat, and clear up here all dryland wheat. Now, so this is in 1965. Here in 2011, and I chose 2011 just because the image was so good. This is all conservation reserve program land. So it's taken out of farming, which in a sediment sense is a good thing. Imagine that erodible material being farmed and the sediment being transported into East Foster Creek, or equally bad, blowing in this environment. It's just a highly erodible landscape. So a grass cover on much of this is a good thing. Beside the chalk hills eroding, there's ample incision into the valley floors. All three of the valleys here have been incised recently. This is the East Fork, and you can see that little stream, and it's incised in places 10, 15 feet. Here's the Middle Fork. Look at that incision and amidst this green wheat field. And that's probably 20 to 30 feet of incision. And this is a tributary to the West Fork. And this was incised. I was told by a descendant of the farm family who lived out here that this was incised in 1948. And I used to bring students out here and talk about recent environmental change, recent geologic change. And I would say it makes no sense to locate a farmhouse on one side of a gully and put the granary on the other side. It just doesn't make any sense. And so that was built before this had been incised. And that is a powerful image of recent change in this environment. So what's going on and actually, let me back up and just give credit. One of my early graduate students, Paul Blanton, measured change in this drainage. So this is part of Paul's work. And then, so what has various agencies, including the Foster Creek Conservation District, done to try to prevent this incision? They've put a lot of money into this structure to try to prevent what's called head cutting, where the stream keeps cutting back up valley. And this has halted that head cutting pretty well. More recently, Fish and Wildlife and the Conservation District have moved toward building structures like beaver dam analogs these little mini beaver dams, and it's hard to see in this photo, but just if you follow my arrow here where I'm moving it, there's a little dam of brush and wood there to hold up water, and that too should pause incision. So this ties to I think he was my last graduate student, Griffin Hansen. He was looking at the effectiveness of these beaver dam analogs in catching sediment. Okay, so as a quick wrap up here, keep in mind that East Foster Creek Valley was likely a pre-glacial floodway, or at least a drainage, a drainage for water on the upper or on the eastern part of the plateau. And that the Foster Creek valleys were covered by the Okanagan Lobe at least once. What we do not have is clear-cut evidence for several glaciations here. Third, East Foster Creek, I said this a couple times, but it flowed west and it flowed east. And that evidence is pretty solid. Foster Creek valleys held ice dam lakes during deglaciation. Some of those were actually Glacial Lake Foster. Some of them were parts of Glacial Lake Columbia. And we see good evidence for that. And that Glacial Lake Foster seems to have existed around 15.5 to 16,000 years before present. And then finally, post-glacial incision has occurred here, and it's been a real management dilemma and a land use dilemma. Do you farm or do you take farmland out of production? And that conservation reserve program land that I showed you is literally farmland taken out of production. So it's resulted in management changes. So a neat place. I hope I've been able to convey to you some of the questions here and just the awesomeness of the Foster Creek drainage. With that, thank you. Thanks for coming tonight, and I'll entertain questions.